We physicists have waited 100 years since 1916 for this photograph.
A quote from Michio Kaku: "Black holes are the testing ground of the divine. Near them, time collapses, space collapses, and the laws of physics as we know them break down." Michio Kaku has finally discovered what is inside a black hole. Black holes are considered the most mysterious objects in the universe, places where space, time, and matter collapse. But for a long time, what really lies beyond the event horizon remained an unsolved mystery. New theories, revolutionary observations by the James Webb Telescope, and groundbreaking ideas from quantum gravity are now shedding light on the darkness. What has come to light will change our view of the universe forever. Imagine a place where time stands still, space curls up, and all known physical quantities shoot off into infinity. These places are so extreme that even the most hardened physicists would prefer to take the emergency exit. Black holes are definitely not just ordinary objects in space, but the craziest phenomena the universe has to offer. Physicist Michio Kaku calls these hellish places God's test laboratory. And that's no coincidence. For here, in the vicinity of these dark giants, everything we think we know about the laws of nature breaks down. Space and time, energy and matter. Everything we know suddenly behaves differently. On the surface, one might think that black holes are simply giant vacuum cleaners in space. But if we take a closer look, they are much more mysterious and perhaps even more creative than we could ever have imagined. Black holes, extreme and secret creators in the universe. Black holes are the new superstars among cosmic phenomena. For a long time, researchers thought that these black giants were just the relics of dead stars or the centers of galaxies. Now, however, it's becoming increasingly clear that black holes are much more than that. Sure, these large black places of destruction and nothingness have always been impressive, extreme, and mysterious in a certain way. But now, the significance of these objects is taking on a whole new dimension. Michio Kaku has published numerous books and articles on black holes and other topics in modern physics. Many years ago, he saw these objects as mysterious entities in the universe whose significance may have been underestimated for a long time. The latest findings from the James Webb mission underscore this view. We now know that galaxies and black holes existed much earlier than previously thought. Images from the world's most powerful telescope show evidence that gigantic black holes may have existed even before the first galaxies and stars. This is a scientific paradox. According to current understanding, black holes are formed when massive stars burn out and collapse. In other words, after stars are formed. But if the black giants were there first, their role in the universe could be of great significance. Black holes are places where the known laws of physics reach their limits. Their density is so high that not even light can escape their gravitational field. Once something crosses the event horizon, it can no longer escape the force field. The radius of the event horizon is described by the Schwarzschild radius. For an object with the mass of our Sun, this is around 3 kilometers. A black hole with the mass of the Earth would have a Schwarzschild radius of only 9 millimeters, the entire mass of the planet in a peanut-sized sphere. The gravity at this boundary is enormous. Near the event horizon of a stellar black hole, space-time can be so curved that a second would take years for an outside observer. Albert Einstein described this effect of gravitational time dilation in his general theory of relativity when black holes were still pure theory. Black holes have only 3 measurable properties: mass, angular momentum, and electric charge. All other characteristics of the collapsed matter are lost. Scientists call this the no-hair theorem. Most known black holes are electrically neutral, but can rotate at their edge at close to the speed of light. The density is also extreme. A black hole with the mass of Earth could be denser than an atomic nucleus. Finally, the pressure and space-time curvature at the center, the singularity, are mathematically infinite. This is where every known theory fails, which is precisely why black holes are considered the ultimate laboratories of physics. They may even hold the key to a new, deeper description of nature. The mass of black holes varies greatly. Stellar black holes weigh just 3 to 20 solar masses. Medium-sized black holes are considerably larger at 100 to 100,000 solar masses. And supermassive black holes at the center of galaxies weigh several billion solar masses. Sagittarius A in the center of our Milky Way is a rather small representative with approximately 4.3 million solar masses. All these figures and extremes are superlatives. However, the real secret of these objects could lie in the small, barely perceptible realm. If black holes are really wormholes or dimensional gateways, they could also be creators. If we believe Michio Kaku, we don't even have to think beyond the boundaries of our universe. It could be that black holes themselves serve as gigantic energy and matter recyclers in our own universe. Gone forever. The information paradox. The information paradox could point us in the right direction. This unsolved problem of modern physics revolves around the question of what happens to information when it falls into a black hole. According to the laws of quantum mechanics, information is the basis of matter and can never be completely lost. This means that if you know the exact quantum physical state of a particle, its history can always be reconstructed, at least in theory. But this would no longer work in a black hole if these places really only serve the purpose of destruction. An object that falls into a black hole disappears behind the event horizon. It's no longer visible to an external observer, and its information is no longer accessible. As soon as the black hole itself finally evaporates through what is known as Hawking radiation, which Stephen Hawking described theoretically in 1974, the information it contains must also disappear. However, this would be a serious breach of quantum mechanics. General relativity says that information disappears forever behind the horizon. Quantum physics says that this cannot be the case. Two fundamental theories of physics therefore provide contradictory answers. Hawking proved that a slight amount of radiation does leave the hole, apparently purely thermally, but this is not certain. It's entirely possible that information also leaves the black hole in a way that is as yet unknown. However, the idea is exciting because if information does come out of black holes again, this information could be recycled, so to speak, and become building material for the universe. Black holes would then not only be machines of destruction, but also creators. The holographic principle goes one step further, stating that information remains stored in the event horizon. If black holes are not true singularities, but rather transitions to other spacetimes, information could migrate to other dimensions or universes and be recycled there. The holographic model, in particular, is currently gaining importance in research. It assumes that all information is stored on the surface of the event horizon, comparable to a hologram that creates a three-dimensional image from a two-dimensional structure. Here, too, black giants would be both cosmic garbage disposals, gigantic recycling machines, and projectors of the universe in which we live. General theory of relativity, from equation to reality. For a long time, the existence of black holes was just a formula in Albert Einstein's notes. Then they became one of the most impressive theoretical predictions of modern physics. The general theory of relativity describes gravity no longer as an invisible force in space, but as a curvature of space-time caused by mass and energy. German physicist Karl Schwarzschild worked on an exact solution to Einstein's field equations, and a strange boundary appeared in his calculations, which later became known as the Schwarzschild radius. At first, this boundary only marked a region in space where gravity is so strong that nothing, not even light, can escape. Back then, around 1916, this result was considered more of a mathematical curiosity. No one seriously believed that such objects could actually exist. It was not until decades later that physicists began to take these solutions seriously. In the 1960s and 70s, interest in extreme astrophysical phenomena grew. It was recognized that stars with more than about 3 solar masses do not end their life cycle as neutron stars but can collapse completely under their own gravity to a point of infinite density, a singularity surrounded by the so-called event horizon. The general theory of relativity provided the foundation. It describes exactly how space-time is curved near a black hole, how light rays behave, and how time almost stands still for outsiders. But it fails at one point, at the singularity. The equations no longer provide meaningful values. Their effect of quantum physics that Einstein did not know must come into play. The real discovery of black holes did not come until the 1970s. X-ray astronomers discovered the object Cygnus X1, whose properties could only be explained by a black hole. Since 2015, black holes could be measured using gravitational wave detectors such as the LIGO system. And in 2019, the Event Horizon Telescope finally captured the groundbreaking image of the event horizon of M87. Extreme, singular, infinite. What lies beyond black holes? Black holes are far more than physical extremes. They are the mystical monuments of the cosmos, places where our minds are shaken, where they form, Not only space is distorted, but also the concept of time. They are singular and beyond all known order. Their existence challenges not only physics, but also our very conception of what reality is. Behind the event horizon, everything measurable ends and everything imaginable begins. At their heart, the classical laws of space-time dissolve. And that is precisely why the centers of these giants are also places of infinite possibilities. Black holes could not only be the end of something, but also give rise to new beginnings. Recent observations by the James Webb Telescope show that black holes may have existed before the first galaxies, and that they are structures that transcend time, dimensions, and space entirely. New theories even suggest that they could trigger small big bangs that gave birth to our universe, or that a new universe could emerge within every black hole. How does it make you feel to think that we too exist in a black hole? Crazy, right? Yet, that is exactly what some hypotheses of quantum physics suggest. Our own universe could have emerged from a black hole in a higher dimensional cosmos. Click subscribe now to receive new and exciting videos on a regular basis.